Good morning, good day, good afternoon, good evening, wherever you are watching from. I really appreciate that fact that you have tuned on to my channel. For those of you who do not know me, this is not Dr. Nandi, and I frequently go live on YouTube on my channel. I've also posted a number of videos on solving math problems. For those of you who think math is a very hard subject, really, I appreciate it. I sincerely think that you may be right, but if you work with me or if you view my YouTube videos, I think that will be a great help to you. My role here is to break down difficult math problem into parts which are easy to use, which are easy to understand, so that you can get a handle or get a grip on the math problem which looks very difficult to you. For example, statistics people think is a very difficult subject. Yes, the formulas are difficult. I appreciate that. But you can break it up in steps. Plus, if you work with a TI calculator, it's not that hard as you think it is. And I'm going to show to you in easy steps how to solve a stats problem. Okay, so again, my name is Dr. Nandi. Please take a look at the videos that I have posted in my channel. I frequently also go live on YouTube solving math problems. I also post fun videos, fun short videos on my channel. Take a look at those too. Okay, so without further ado, let's get started on the problem that we are talking about. I really request you that you watch till the end of this presentation. It will not be long, I guarantee you. You will be able to appreciate what steps I have taken to solve a seemingly difficult stats problem. I appreciate if you please watch till the end of this video. If you like my video, please give me a thumbs up. Again, that motivates me. Please subscribe to my channel after you watch my videos. So without further ado, let's get started. I will share my computer screen with you. This is a problem on sampling distribution of sample proportions. For those of you who have no idea on what is a sampling distribution, it is basically a probability distribution. Okay, and in this case, the variable that we are whose probability distribution we are describing is a sample proportion of success. For example, in this particular problem, from a survey of 400 people, it was found that 51% of them enjoy watching a dog in a Zoom meeting with co workers. So they surveyed 400 people and they found it was that 51% of them enjoy watching a dog in a Zoom meeting. Okay, so the sample size is 400, and out of them, 51% enjoy watching a dog in a Zoom meeting with co workers. So the first thing you do is you identify sample size, which is n. So your sample size is n is equal to 400, and p, your population proportion of success. What is success here? That may be the question. Proportion of success. Success is to watch a dog in a Zoom meeting, is to enjoy, watching a dog in a Zoom meeting. Watching a dog in a Zoom meeting. A dog in a Zoom meeting. That is your success. Who has defined it? The way the problem is constructed, the problem statement tells us that the success is to enjoy watching a dog in a Zoom meeting with coworkers. And P is given as P. So P is given as 0.51. 51% converted to decimal is 0.51. So first we calculate number. So we calculate number of successes. Number of successes is equal to n times p. In this case is equal to 400 multiplied by 0.51. That is the population proportion of success. So 400 multiplied by 0.51 is 204, is equal to 204, which is greater than 10. We also calculate the number of failures, number of, so this is number of failures. That is number of people who do not enjoy watching a dog in a Zoom meeting is n times 1 minus p. So it is 400 multiplied by, or left parenthesis, 1 minus 0.51. And that is equal to, I will use my TI-84 calculator and I will do 400. I type 400 on the calculator screen, 400, and then left parenthesis or left bracket, 1 minus probability of success is 0.51. Notice 1 minus 0.51, which is actually 0.49, is the probability of failure. This is the proportion of people who do not enjoy watching dog in a Zoom meeting. And 400 times 0.49, or 400 in parenthesis, 1 minus 0.51 is equal to 296. Is equal to 196. So this is over here, 196. That is also greater than 10. Now we can write, since number of successes, number of successes and number of failures are both, this is a requirement, are both greater than 10, are both greater than 10, we can assume, we can assume that the sampling distribution, that the sampling distribution of sample proportion, sampling distribution of sample proportion, of sample proportion, sorry, of sample proportions, sample proportion. This is given as p hat is bell-shaped, is bell-shaped, or normal, or normal. Okay. Now, if I move this a little bit up, from central limit theorem, for the sampling distribution of p hat, distribution of p hat, sampling distribution, mm, for the sampling distribution, mu p hat is mean is equal to population proportion of success. Remember, this is the population proportion of success. Which proportion of success? Now it has been already given to us that P is equal to, so mu P hat is equal to P equal to 0.51. Also, also sigma P hat, which is the standard deviation of the sampling distribution. Standard deviation of the sampling distribution of the sampling distribution is sigma p hat is equal to square root of p times 1 minus p over n. Okay, so let's see, if you go back, you will see the sample size n is 400 and p is of course 0.51. So how do I do this in the calculator, this long formula? Okay, so what I do is, to calculate this is easy with a calculator. So I'll show it to you in a minute how to do it. So equal to, we will press the second button in the calculator, second, then x square button gives me the square root. Inside the square root, I will type the p-value, which is 0.51, then left parenthesis 1 minus 0.51, which by now we know it's 0.49, and then I divide by the sample size, which is n equal to 400. Okay, everything under the square root and then enter. This 400 is the sample size. Okay, so if I do my calculation correctly, I'll first put the calculator on, then I will press the second button on the top left corner, then the x square button, which will give me the square root. Inside the square root, I will type 0.51, left parenthesis 1 minus 0.51, right parenthesis, then divided by the sample size divided by 400. Okay, so that's how it looks in the calculator. Okay, so, okay, and the answer is equal to, after I do the enter, I get equal to 0.0002499. Okay, that's the value of sigma p hat. Now, let me take a minute and draw the sampling distribution of p hat. So, okay, so I'm going to draw, change the color of the ink to make it a little bit different. Okay, and I will draw the sampling distribution of p hat. It's a bell-shaped curve as we discussed. P hat on the horizontal axis. The center, where the relative frequency is highest, is where mu p hat. So as we have calculated, mu p hat is equal to 0.51 and sigma p hat is equal to 0.02499. So this is the mean of this distribution. This is the standard deviation. The question is, will a majority enjoy a dog? Or let me just review the question. The question says, pa- part B, is it reasonable to conclude that more than half? More than half means a majority. Okay? More than half. Okay? So, going back, the center is 0.51 over here. So this is 0.51. This might be 0.5 over here. More than 0.5 is this portion. So we want to find out what is the probability that p hat is greater than 0.5, or we find the area to the right of 0.5 of the vertical line at p hat equal to 0.5 under the sampling distribution curve. So this is the sampling distribution under the sampling distribution curve. That's what. Remember, in probability bell-shaped curve, probability distribution bell-shaped curve, area under the curve is the probability. So just to make sure that everybody is on the same page, this is the sampling distribution. Sampling distribution means probability distribution of p hat. Distribution of p hat. Of p hat, which is sample proportion. And we want to find out what is the probability that p hat is greater than 0.5? Well, it's a bell-shaped curve, so we are going to use our calculator TI-84. Specifically, we will use p hat greater than 0.5 as normal CDF. Okay, normal CDF, cumulative area, that's what the C stands for, area under the normal curve, under the normal curve. Okay, so how do you get normal CDF in TI-84? So in TI-84, let me make sure that we are on the same page. We are on TI-84. In TI-84, press second key and then words key, then scroll down to number 2, which is normal CDF. Okay, so if I move it a little bit up, okay, so first it asks for lower. Lower is you're starting your calculation from point 0.5. So second verse, okay? You're going to number 2, normal CDF. Lower is point 0.5. Upper is 1. Upper is 1. Then second button and comma button. So I'll write it down. Upper is 1. Then second button and then comma button. And then small cap e. This is means 1 followed by 99 zeros. That means very large number on the right. That's your upper boundary. 1e99. What is your mean? Mu. The next is mu. Mu is 0.51 is equal to the population proportion of success. And sigma we already calculated is 0.02499. So we type that out. Mu is 0.51 and sigma is 0.02499. Then we go down to pest and hit enter twice. On pest, bring the cursor on pest and hit enter twice. Enter twice. So P. Now remember we are trying to find out, right here, P hat greater than 0.5 is equal to, after I hit enter twice on pest, it is 0.655. So it is 0.6554 is the answer. So if we go back, the question was, is it reasonable to conclude that more than half? Answer is yes. So we write it down. Since the probability of p hat greater than 0.5 is 0.6554, which is 65.5%, it is reasonable to conclude that more than half of the people that more than half of the people enjoy watching a dog watching a dog in a zoom meeting in a zoom meeting with the co-workers. Okay, now let me briefly summarize. Hold on your breath. I will briefly summarize. Just to summarize how we got to this point. I want to make things easy for you. Believe me. So just hang on a few more minutes, okay? So, what was the problem all about? From a survey of 400 people, it was found that 51% of them enjoy watching a dog in a Zoom meeting with co workers. Find the mean and the standard deviation of the sampling distribution. N is 400, P is the population proportion of success. What is success? Is to enjoy watching a dog in a Zoom meeting, okay, with co workers. P is 0.51. Okay, so number of successes is n times p is 400 times 0.51 is 204. That has to be greater than 10, and that is. And then number of failures is n times 1 minus p is also 196. That is also greater than 10. Since both the number of successes and number of failures are greater than 10, we can assume that the sampling distribution of p hat is bell-shaped or normal. Now we can use the central limit theorem. Mu p hat is the mean of the sampling distribution, is population proportion of success is 0.51. Standard deviation of the sampling distribution is given by this formula, which you use your calculator, second x square. Remember to press the second button, otherwise you do not get the x square root. Inside the square root, 0.51, left parenthesis 1 minus 0.51. This is the probability of failure divided by the sample size of 400. Sigma p hat is 0.02499. 0.2499. We want to find out what is the probability that more than half point, that is p hat greater than zero point 0.5. So in a normal distribution, probability of an event is the area under the curve, in this case to the right of zero point 0.5. That is the key thing. Probability is the area under the normal curve. In this case, greater than, hence it is to the right of the vertical line drawn at zero point 0.5. Okay. And we used again TI-84, second verse, second button, and then verse, which is in the third row. Then number 2 gives you normal CDF. Lower is zero point 0.5, upper is very large number on the right. Remember, the normal curve stretches to infinity on the right, is 1e99. And then mu is 0.51, sigma is 0.02499 paste. And we get a probability that the sample proportion greater than zero point 0.5 is 0.655, or there's a 65.5% chance that more than 50% of people enjoy watching a dog on a Zoom meeting with co-workers. Since this is greater than 50%, yes, a majority of the people, okay, enjoy watching a dog in a Zoom meeting with co-workers. Was that very difficult? Let me know. Can I improve somewhere in your presentation so that you do not get lost? Please write to me. Please drop me a note. Please, if you like my video, give me thumbs up. That really motivates me. If I can improve, suggest that to me. And if you like this video, give me a thumbs up. Again, that motivates me. If you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. Please, at the same time, click on the notify bell button. You'll be notified every time I upload a new video. And again, please do not forget to watch me tomorrow when I will be loading another interesting video or uploading another interesting video. Okay. So, so, okay. So let me get out from here and I will see you next time. Take care. Bye.